Welcome to everyone. I'm James Jensen, a contractor supporting Western Area Power Administration in the Office of Indian Energy Policy and Programs Tribal Energy Webinar Series. I'm filling in for Randy Mannion as today's webinar chair. Today's webinar, titled Tribal Microgrid Case Studies, is the 11th and final webinar of the 2018 DOE Tribal Energy Webinar Series. Let's go over some event details. Today's webinar is being recorded and will be made available on DOE's Office of Indian Energy Policy and Programs website, along with copies of today's PowerPoint presentations. These will be available in about 1 week. Everyone will receive a post-webinar email with the link to the page where these slides and recording will be located. Because we are recording this webinar, all phones have been muted. Today we will answer your written questions at the end of the first and third presentations. You can submit your questions at any time by clicking on the question button located in the webinar control box on your screen and typing your question. Let's get started with opening remarks from Lizana Pierce. Ms. Pierce is a Senior Engineer and Deployment Supervisor in the Office of Indian Energy Policy and Programs, duty stationed in Golden, Colorado. Lizana is responsible for managing technical assistance and education and outreach activities on behalf of the office, implementing national funding opportunities, and administering the resultant tribal energy project grants and agreements. She has 25 years of experience in project development and management and has been assisting tribes in developing their energy resources for nearly 20 years. She holds a Bachelor's of Science degree in Mechanical Engineering from Colorado State University and pursued a Master's in Business Administration through the University of Northern Colorado. Lizana, the virtual floor is now yours.
Thank you, James. Every time you read that, I feel so old. Anyway, hello, everyone. I join James in welcoming you to the final webinar of the 2018 series. This webinar series is sponsored by two U.S. Department of Energy organizations, the Office of Indian Energy Policy and Programs, otherwise referred to as the Office of Indian Energy for short, and Western Area Power Administration, or WAPA. The Office of Indian Energy directs, fosters, coordinates, and implements energy planning, education, management, and programs that assist tribes with energy development, capacity building, energy infrastructure, energy costs, and the electrification of Indian lands and homes. To provide this assistance, our deployment program works within the Department of Energy across agencies and Indian tribes and organizations to help Indian tribes and Alaska Native villages overcome the barriers to energy development. Our deployment program is composed of a three-pronged approach consisting of financial assistance, technical assistance, and education and capacity building. This Tribal Energy webinar series is just one example of our education and capacity building efforts. The webinar series is part of the office's efforts to support fiscally responsible energy business and economic development decision-making and information sharing amongst tribes, and is intended to provide attendees with information on tools and resources to develop and implement tribal energy plans, programs, and projects. Highlight tribal energy case studies, of which you'll hear a couple today, and identify business strategies tribes can use to expand their energy options and develop sustainable local economies. In today's webinars, we will focus on microgrids and the opportunities and challenges that these systems present as microgrid technology continues to become more affordable, reliable, and capable. This webinar will provide you an overview of microgrid systems and technologies and how they can be used in tribal communities for emergency situations to provide reliability or increase independence. Speakers will highlight the benefits and challenges of tribes considering developing, owning, and operating a microgrid. Two case studies will share insights on their successes in their development of their own microgrids. So we hope this webinar and the webinar series is useful to you. We also welcome your feedback, so please let us know if there are ways we can make the series better. And with that, I'll turn the virtual floor back to James.
Thank you, Lizana. On today's agenda, we have three presentations. I will introduce all of the presenters now. Our first presenter is Jana Gagnon. As Sustainability and Government Affairs Director for Blue Lake Rancheria, Jana leads the tribe's strategy for community resilience and rapid transition to zero net carbon emissions. She has managed over $15 million in projects, including a community microgrid with solar, photovoltaics, and battery storage. As a result, the tribe is saving approximately $300,000 per year and has increased employment by 10%. As an appointee to the U.S. Department of Energy's Indian Country Energy and Infrastructure Working Group, Jana also works with other governments and stakeholders on zero carbon sustainability. Jana will be presenting a case study on the Blue Lake Rancheria microgrid. Jana will not be available to stay on for the whole webinar today, so she will answer your written questions immediately following her presentation. Following Jana, we will hear from Dan Tan. Dan is Program Manager of Smart Grid Research and Development within the U.S. Department of Energy Office of Electricity Delivery and Energy Reliability. He is responsible for developing and implementing a multi-year research and development program plan for the next generation smart grid technologies to transform the electric grid in the United States through public-private partnerships. He has served as Acting Assistant Secretary of Power Systems Engineering Division within the U.S. Department of Energy Office of Electricity Delivery and Energy Reliability. In that capacity, he was responsible for managing development of projects for next generation electricity delivery technologies and supporting activities to accelerate their introduction to the marketplace. Key activities in the Power Systems Engineering Division focus on smart grid research and development, energy storage, and cybersecurity for energy delivery systems, all in support of OE's mission to drive electric grid modernization and resiliency. Dan holds a Bachelor's of Science degree in Electrical Engineering and a Master's of Science in Business Management, both from the University of Maryland. Our final presenter will be David Thomason. David is a project organizer for CP Energy Services, where, among other things, he is managing the development of Citizen Potawatomi Nation's microgrid. David has over 35 years of experience in the field of critical power generation, distribution, and control in the design, installation, and maintenance of multi-megawatt redundant UPS generator, data center, and industrial applications. David is an enrolled member of the Citizen Potawatomi Nation and is passionate about expanding tribal sovereignty through nation enterprises and building a tribal reservation electrical utility. So with that, we'll get started with Jana's presentation. We'll pause one moment while I bring it up. All right, Jana, it should show up momentarily. Where's yours?
I see it. Thank you. Thanks, everyone, for attending, and thanks to the Department of Energy and WAPA and the Office of Indian Energy. These webinars, I think, are a very efficient way, especially in terms of greenhouse gas emissions, to talk about these very important projects that are happening in Indian country, and I'm delighted to be here. So I was asked to just briefly talk about what is a microgrid. For those of you that are relatively new to this topic, microgrids come in a variety of flavors and functionalities, but essentially, I'll talk about it from our perspective. Essentially, I think the most common reference is to a mini electrical grid that oftentimes can disconnect and reconnect to the main larger regional grid. Maybe it's your investor-owned utility or your co-op or the other regional power supplier. And microgrids can operate in grid-connected mode and islanded mode. And when they're in islanded mode or disconnected from the main grid, they generate using their own sources of electrical generation and use their own power, in our case, for as long as we need to. So today I'm going to talk about our microgrids, plural, at Blue Lake Rancheria. I'm going to talk about the framework within which we develop microgrids, which is decarbonized lifeline sector approach. And these are economy-enabling investments that the tribe is making in that energy lifeline sector to support its governmental operations and its economic enterprises. Next slide, please. So a little bit about the Blue Lake Rancheria. It is federally recognized. We are located in California. There are over 100 federally recognized tribes within the state of California, so we have a big cluster out here. The Blue Lake Rancheria tribe is small in terms of members, but large in terms of ambition. And so we have a number of governmental departments, including a formed utility, Office of Emergency Services, and a number of economic enterprises, including a casino and a hotel and event center. We have about 400 employees, so for our rural environment, we are one of the largest employers. We do, despite our small size and small capacity staff, try to work and conduct significant outreach at the local, state, and federal level. And we serve on a lot of task forces around energy and sustainability issues and climate action. And for our work in microgrids and in other sustainability efforts, we've received some humbling recognition, including some technological recognition in terms of projects of the year, but also in terms of emergency preparedness. We're pretty proud of it, the Whole Community Preparedness Award is a national award from FEMA last year. Next slide, please. So this is a quick reference of where we're located. People think of Sacramento or San Francisco as Northern California, but you actually go there and drive 6 hours north, and that's where we're at. So we're in a very rural, geographically isolated area. Next slide. And because of that, we have some issues that lots of tribes who are in rural, geographically isolated areas also experience. And most of our impacts that we need to develop resilient strategies for, especially around lifeline sectors, which is the underpinning of our energy lifeline sector and our microgrid development, are things that are on this list. So landslides, wildfires, we've all seen the devastation that those have caused in recent years. We're in a prolonged drought that's creating havoc and contributing to these wildfire conditions. We have extreme storms and floods and sea level rise. And all of those bullet points are being amplified much more rapidly than even was predicted by climate change and global warming. Next slide, please. So these are just a quick photo of the landslides. These two landslides are across our two main arterials to the area, and they happened simultaneously, and they took 6 months to recover full use of those roads. So when we talk about developing a resilient strategy on the north coast of California, we really mean it because we have to deal with these things on an annual basis and sometimes a monthly basis and sometimes for extended periods of time. Next slide, please. This is a snapshot of our earthquake and tsunami threat. We're in one of the most active seismic zones in the country. The Cascadia subduction zone is offshore. 3 plates converge there, and we're one of the only areas in the country that can experience magnitude 9.0 or greater earthquakes. Next slide, please. And this is just some detail about our energy supplies. So we have a 115 kV transmission loop that serves our area, but that runs through wildfire country. We're import restricted to 70 megawatts. We have 1 10-inch natural gas line. Our diesel fuel and other fuels that are barged in or trucked in are expensive, and as you saw in those photos, are subject to supply disruptions. And so we want to make sure that we really look at a broad array of resources for both business as usual and continuity of operations and emergencies. Next slide, please. So our microgrid, which is really what we're here talking about today, is born out of that situation. And we have some incredible partners that allowed us to go out and do this project, which I'll talk about in a minute. But I wanted to give you an overview of kind of the technology. So we purchased our distribution infrastructure from our local investor-owned utility, PG&E. So we take control, our utility takes control of that infrastructure at the 12.5 kV level. So, relative to WAPA and big transmission lines, this is sort of lower voltage, but it's still pretty big for us to take on as a community. In terms of power generation, we have solar, PV, and battery storage. So right now we have about 420 kilowatts AC of solar. As I'll talk about in a minute, we're looking to double that in the next year and a half. We have basically a megawatt hour of battery storage, 500 kilowatts of power there. Just to give you a sense of perspective on that, that battery system alone can power our whole campus on New Year's Eve when everything's going for 2 full hours. Now that doesn't seem like a lot of time, but it's actually a really powerful system, and the footprint of that is super small. It's probably a 10-foot wide by 20-foot long pad is all it takes to get that battery in there. So we do have some legacy diesel gen sets as part of our generation mix, but that's because we've had them since 2000, about 2000 vintage. They have plenty of life left on them. We don't like them. They're dirty. They cause emissions that we don't want to have in our community. And we're looking to replace them as soon as possible with battery storage. But until then, they're there. We don't want to strand those assets, but we only use them in a real significant emergency. And so they're relegated now with our new microgrid to deep backup. Our microgrid can seamlessly island, as I said, disconnect, reconnect from the utility. We have load sheds built into the system, so we can press a button and our HVAC will cut down to 50% and go on a rotate basis, cut our power that way. And what we did at the beginning of the project was we looked at what are our critical loads, and we matched that up to a matrix about the length of any power outage. So if it's a 3-hour outage, we're really not going to do any load shed. If it's a 3-day outage, we're going to do some load shed. And if it's a 3-week outage, we're going to take it down as far as we possibly can, and we're going to only have those life, health, and safety level needs met with our power system, so we can extend it as long as possible. Our loads in our campus that is served by the microgrid are about 0.5 megawatt, so not that much. We've done some really good job on the energy efficiency side, if I do say so myself. And but our peak could be as much as 1 megawatt, so we have to kind of size the system for that. The microgrid serves, as I said, our government offices, casino, hotel, and other economic enterprises there. And then, of course, all of the infrastructure that serves that campus. Next slide, please. So this is a bird's eye view where you can kind of see where some of the components are laid out. In the lower right-hand corner, you'll see a box that's got an arrow to it that says PCC. That's the point of common connection with PG&E, our local utility. And that was one of the most significant parts of the project, was understanding how that point of common connection with the utility had to be done per utility regulations, but how it also could be optimized for our microgrid operations. And again, we will provide details. We provided a huge report out on this system. It's available online. I can provide people with that information if you're interested. Next slide, please. So really, our microgrid is a resilient strategy. But these are the reasons, the details about why. So obviously, it powers our critical infrastructure. We have continuity of operations now that we didn't have before. And as I said, I'll say it again, we approach these things in a lifeline sector paradigm. So we look at energy, water, food, communications and IT, and transportation. And we start with energy because that lifeline sector supports all the rest of them. We are a certified American Red Cross shelter. So our microgrid also would serve that facility in case that ever becomes a need. And then I always get the question, okay, but what about the costs? We're saving about $200,000 a year through the microgrid operation alone. And the other thing I should talk about is that the microgrid centralized management system automatically has our rate tariff embedded in it. So it is on autopilot 99% of the time, where it's just optimizing the solar, the battery storage. It's arbitraging that system to even out and reduce our energy costs. So it starts with the most expensive energy, which for us is between 12 and 6 p.m. every day. There's some details to that seasonally and things like that, but we have time of use rates. So all of that is just plugged into the system. And when the rates are changed and they're certain to change, we just plug that new tariff in, and then the system automatically optimizes for that tariff. So that's a wonderful benefit to the system too. It does help to strengthen the grid in terms of we can achieve greater demand response. So when PG&E says, hey, it's 145 degrees in Reading, we need you guys to go offline so we can fulfill that air conditioning need, we can bring more of our campus offline than we could before, and until they say we can go back online, and we can make a little bit of money through those programs too. It improves cybersecurity a bit in that we have our own cybersecurity platform over our own microgrid. And again, details on that if you would like it. I can't say enough good things about solar plus storage. The cost is amazing. The O&M is low. The vendors that we have worked with have been incredible. We're just very, very happy with how all of the solar plus storage generation has come together for us. And then, of course, we've been able to create new jobs. This microgrid, the tribe made the choice to invest some of the savings into new positions, both on the IT side and the facility side, to manage this system and expand it. So we've been able to increase our employment by about 10%, most of which is augmented by the savings achieved by this system. And then, of course, we're hoping that it encourages replication, that whoever on this phone call and this webinar want to do microgrids, that these projects are going to be easier for you because of what we've done and learned, and hopefully you can avoid some of the challenges we've had. Next slide, please. So quickly about our partnership, the California Energy Commission provided us with a $5 million grant through their EPIC program, which is a ratepayer-based research and development and demonstration project fund. I can't say enough good things about that technological and demonstration and R&D investment by the state. We have turned that $5 million, we think, through this incredible partnership into a lot of value for the overall energy sector. And we just need to highlight that across the country, states, federal government, tribes need to keep their eye on that research and development funding investment priority. We worked closely with our local university, and I tell tribes this all the time. If you have a local university with an engineering department and you're interested in, especially in energy feasibility studies and energy work, reach out to them and try to form a partnership. We're lucky that we have in our area one layer above that. We have actually an energy research center. So we have certified engineers at the university that have been our project managing engineers and our systems integrator, which is incredibly important in a microgrid. So it does a couple things. One, it ties us into STEM education, and we have a lot of students that come out to the Rancheria and work on our projects to learn about how all this stuff is developing. They do feasibility studies for us. So there's that student participation and tribal member student participation that we love about these kinds of projects. But the engineers at the university are intrinsically interested in knowledge transfer. So the tribe's capacity is built through these projects in a much more efficient way, just because of how everyone's philosophy is oriented, than if we were to go out and do a private contracting, a private engineering firm play. And so we've been very happy with our university partnership and highly recommend it. We worked with the national labs. We're incredibly grateful to Idaho National Lab because we did hardware in the loop testing for the microgrid. We took the system to Idaho. We tested it. We used that test system to train up our staff on it. And we tried to break it and fix it and break it and fix it before we took it live on the Rancheria. It was an incredible partnership, and we're very grateful. Our utility was a great partner on this project because utilities are looking for their next business model, and microgrids are for sure, and distributed energy resources are for sure going to be a part of that. So we don't have time to go into all of the details. Just safe to say that a partnership is necessary for a microgrid, and we were fortunate to work with some of the most amazing companies in the energy sector, and we're very grateful for that. Next slide. So I'm not going to spend a lot of time on this, but I will say that our microgrid, one of the goals was decarbonization. So we know that we have to move quickly to address climate change so that we don't have to suffer the impacts that we've all seen just in the last few months. So we reduced CO2 by 195 tons a year, maybe even more than that as we dial the system in. It enabled us to do more rapid deployment of solar and storage within our region. The solar industry as a whole has broken even on its entire carbon debt. So every single solar panel we add from here forward allows us to absolutely reduce the causes of climate change. So we should do more solar, as well as other technologies that work for us. Next slide, please. So this was a fortune cookie that I opened a couple weeks ago, and I liked it. So we did succeed at our microgrid with the help of our partners, and so we're going to try something harder. Next slide, please. We have another microgrid that's under construction right now at our gas station, and this is called our Solar Plus microgrid. It is again funded by that California R&D fund, the EPIC program, at least in part. The tribe's paying about 50%. It has solar that you can see in the photo there on the canopy, and it has battery storage in the back of the building. So it's the same type of model as our big microgrid. So we have a microgrid backup to our microgrid. But the idea is to create a resilience package with advanced building controls for energy efficiency for small to medium commercial buildings. And we have a gas station and a convenience store, so that's what we're starting with. But the hope is that this is a more cookie cutter approach to a microgrid that anyone can put on their gas station, convenience stores, or other buildings of this kind, grocery stores, small fire stations, that kind of thing. Next slide, please. So this serves a serious emergency preparedness service for us in rural areas, because gas stations really do provide all of those lifeline sectors that we're talking about. And in an emergency, a gas station convenience store might be the only critical infrastructure that's around in rural areas. And so when we've seen these hurricanes and things, gas stations are taken out, and that affects emergency responders, and it affects the ability of people to get diesel for their own generators at home and keep their medicines cold, and all of these things that actually could be solved with a resilience package for a gas station. Next slide, please. We're also expanding. We're going to try to double our solar. We're going to double our battery storage. California has an incentive program that's meant to drive down the cost of batteries, and we're taking advantage of that. We're developing a smart water grid, so that's at the energy water nexus. We're migrating to electric vehicles, so that's at the energy transportation nexus. Next slide, please. And I just want to say finally that it's really, the partnership is amazing, but it's all about steady, consistent tribal government leadership. The tribal government gave the program a long runway. We started with energy efficiency 4 years ago, and today we have two robust microgrids that has cut our costs by probably 30%. So we've done a lot in 4 years, but that's because the tribal government leadership was willing to invest some of its economic enterprise revenues in it to leverage other funding that we brought in the door. They were willing to invest some of the savings as another sort of found revenue source into these projects. Um, and we're doing we're doing monitoring and verification. So we're tracking on how much money we're saving, how many tons of greenhouse gases we're reducing, and we're reporting those things out as well. Next slide, please. So just these are some development strategies that we've had success with. We plan and set goals. We found funding through utility incentives, federal funds, state funds, as I've talked about. And then we really did our homework on policy. What kinds of net metering interconnection agreements can we have? How can we work with, which is what we're doing right now, actually, as I speak, how can we work with our state to raise the profile of tribal governments within some of these tariffs and other programs? And so we keep our eyes on all three of these areas simultaneously, and I think that's been a winning formula for us. Next slide, please. So when the tribe went into the energy development and the sustainability project space, they got clear on the goals. And the goals are to power everything with electricity and to create that electricity from zero carbon sources. So we need to do a better job of creating energy from sources that don't impact our health and impact our environment. And the good news is we have the technology to do it now. We need to internalize the health and environmental costs with our energy and transportation sectors in particular. We need to improve enforcement of those. We need to stop relaxing regulations around specifically health protections, but writ larger environmental protections. We need to question the carbon life cycle analysis, the carbon footprint of basically everything we do. And I've been doing this concertedly for 4 years, and I'm telling you that it is a little bit difficult. But once you get into the habit of it, it's actually super creative and motivating, and it's one of the best parts of my job. And then we need to keep our eye on our other tribal resources and what we can do to look at things like carbon sequestration. We need to support things like carbon pricing and carbon markets. We almost got there with the Clean Power Plan, and hopefully we'll get there again. And then obviously the most recent science, most recent studies from the current administration are very clear. We have a little over a decade to turn this ship, and luckily tribes are leading the way. And through the technologies that we already have, we just can move faster and achieve that goal. It is, without a doubt, our moonshot, and we need to make it happen. Next slide, please. So this is a photo from NASA. It's the famous pale blue dot or blue marble photo from our moon landing, and I just love this shot, and I wanted to leave that with you. So thank you so much for your attention.
Thank you, Jana. Very interesting project and great presentation. We do have a couple of questions that have come in, so I'll read them off to you, and to the audience. Feel free to ask some more if you think of any. So first question: is the microgrid only serving critical needs and not operational needs?
It's serving all needs. So it serves, but in business as usual, non-emergency, when we're connected to the grid, we do import a little bit of PG&E power. We do that because our interconnection agreement prevents us from exporting over 100 kilowatts of power onto the grid. That's just the way that the agreement is structured, and it's fine with us because we use all of our power that we can possibly generate. So business as usual, it serves all of our needs, but it does import a little bit of power from the utility. In an emergency, it serves, again, everything that we do, but it does it with our own generation sources. So that's at the point where we would need to load shed to reduce the loads so that we can balance all that out.
Interesting. So to follow up on that, is the whole system metered at the point of common coupling?
That's right.
Yep. Okay.
We have a single meter, and we went from basically a retail customer to a wholesale customer, what they call secondary customer to primary customer with PG&E. So we're primary customer. We take our power at that point of common connection at the 12 kV level, and then we are responsible for the rest of it past that PCC point.
Gotcha. Okay. Another question here. Actually, two that are related. Did you experience any delays in obtaining local, county, or community? Oops, new question came in, so I lost it.
Delays like
local,
in permitting?
County, state, or federal permits, as well as PG&E. Did they cause any delays?
No. So I'll take it in reverse order. PG&E was an extraordinary partner. At one point, their value engineering actually helped us save about $420,000 on the project cost. So we experienced zero delays with their interconnection. I would say, if anything, they were waiting on us. And we had about, I don't have the details in front of me, and it's been a while since I've gone through them, but we had about 4 separate agreements with them that we had to complete for this microgrid. I can make those available to people, but in all of those cases, they were incredibly helpful and right on time. There were no delays. As far as the permitting on the larger basis, we had to do, because we used state funds, the state had to conduct a parallel CEQA review, but it ended up being a negative declaration, and there were 0 comments, and it really went smoothly. But again, that's because it's solar, and it's all on tribal lands, and there were no off-reservation impacts. The tribe did its own environmental review process and came to a finding of no significant impact. We did do a stormwater pollution prevention plan, even though maybe technically we didn't need to because we were within a really safe construction window. But we did it anyway just because it's good practice, and we like to have those best practices during construction. But there were no delays, and I attribute it to the fact that it was solar plus storage. It wasn't a controversial source of energy, and fairly simple to get installed.
Great. So, Jana, we have quite a few questions here. Feel free to let me know if you need to run. We can certainly send you the questions specifically, but
okay.
I'll just keep going until you tell me to stop.
Yeah, how about 5 more minutes, and then I'll have to go.
Okay. All right. Sounds good. Let's see. Some utilities are resisting microgrids in spite of FERC Rule 841 in regulated states. Do you have any idea how to correct that? And if you aren't familiar with it, we'll probably ask this to the other analysts later.
Yeah. I'm not familiar with that actual rule. I'll say that up front. However, I will say that, listen, we started our microgrid basically in 2015. We commissioned it in July of 2017. So it took us a year and a half to build it and commission it, which is super fast. Actually, it's not super fast, but it is moving along at a fairly big clip. But even in 2015, microgrids were new. They were firmly outside, certainly the investor-owned utilities core business model, and we were really respectful of that. And we had a bunch of meetings up front, which I highly recommend, with the utility to explain what we were doing. Of course, having the state funding, I think, and being a part of that grant probably helped because, there was sort of a state nexus there that was in addition to the utility. But now I'm hoping that whatever resistance we have seen in the past is going to start eroding, because microgrids are for tribal areas, for tribal communities, and for other areas that may have energy access problems or energy reliability problems or end-of-the-line problems. Microgrids are a relatively cost-effective way to reinvigorate the grid. And at least in our case with PG&E, PG&E has really embraced that idea. They'd rather build, well, I can't speak for them. The sense I get is that they're interested in building microgrids as maybe an alternative to big transmission lines, for example. And they are actually involved in the latest microgrid projects. They're keeping their hand in, and they're actually going to be a microgrid owner and participant. So I think it's moving forward, and I think maybe, now that some of these things are getting built and they're saying, yeah, they're safe, we can do this, and the proof of concept has happened. I think some of the resistance may hopefully erode.
Great. Another question: were you required to have a strategic energy or energy reduction plan in place to be eligible for the federal funding? There was federal funding.
We didn't have federal funding on this project. We had state funding that was used in part to fund INL activities. We actually haven't used a lot of project funding on the federal level. We've used feasibility study funding and things, but our project funding has come primarily from the state. We have a strategic energy plan, and the DOE, actually Office of Indian Energy, if you go on their website, little plug here, they have a strategic energy plan template that we used because why recreate the wheel? We haven't used this resource, but the technical assistance that's been provided through the Office of Indian Energy to develop those strategic energy plans has been robust to tribes, and I would encourage anyone to take advantage of it. But it hasn't been a requirement of our funding.
Gotcha. What university did you partner with, and what was the name of the center?
Sure. So it's Humboldt State University. It's part of the California State University system. And the name of the center is the Schatz Energy Research Center. So SCHATZ, the Schatz Energy Research Center at Humboldt State University.
Thank you. How do you get more graduate students involved with the policy side of microgrids or indigenous studies?
Sure. So, yeah, I think that's a great question, and it'll probably have to be my last one, unfortunately. But I will respond to all the questions that are emailed to me. So we'll make that happen. So we were approached by the university to be a faux client, kind of client in air quotes, for graduate capstone projects and other graduate class projects in the engineering department. But we've also worked with natural resources and the business department, a number of departments at the university. We've had a number of graduate students, groups, classes, come out and do feasibility studies for us on a wide variety of topics, including policy. So how do you get that to happen? Just call the engineering department and reach out to those specific professors who teach those courses and say, raise your hand and say, we're happy to be a host site for some of these capstone and graduate study projects, and here's some of the things that we are interested in looking at. So we've had them do anything from air quality data to solar feasibility to net metering aggregation studies. So just reach out. They will love it because they're always, I think at the graduate level, at least at Humboldt, it's this way. They're always looking for good projects to do, and people love working on projects for tribes just because it's something that's relatively unusual and enjoyable for the students.
Great. Well, thanks, Jana. We really appreciate your time and your flexibility to squeeze us in today, and we'll email you the questions we have, and you can get back to the requesters directly. But thanks
Wonderful.
for your time again. Appreciate it, your presentation.
Thanks, everybody. Have a good day. Bye-bye.
All right, so with that, we will move on to Dan Ton from DOE. Hold
Great.
on, Dan, while I bring up your slides.
Okay. While you're doing that, I wanted to say again that I'm with the U.S. Department of Energy, and I'm within the Office of Electricity. The name has changed from a longer name to a shorter name of Office of Electricity, and within that, I am in the Advanced Grid Research Division. So today, I'm going to talk about the Microgrid R&D program at the U.S. Department of Energy. Next slide, please. So within the Advanced Grid R&D, we have four main areas. The first one is focusing on the distribution system, and it's called Resilient Distribution System. That office has four main programs. One of them is a microgrid, where I'm at, and the other one, including transactive energy, low-cost sensors focus, and advanced distribution management systems. In the transmission reliability portion, we have focused on two areas, transmission reliability program and advanced grid modeling. And then we have transformer resilient and advanced component, where we are focusing in other advanced components, power electronics, part of the grid R&D, and also with the geomagnetic disturbance areas and electromagnetic pulse areas. And then finally, in the energy storage system, we have R&D in all aspects of energy storage technologies. Next slide, please. So I would like to, before I go into details about microgrid, I also wanted to add the DOE definition of microgrid. The microgrid in our definition is a group of interconnected loads and distributed energy resources within a clearly defined electrical boundaries that can act as a single controllable entity with respect to the grid. And so the microgrid can connect and disconnect from the grid to enable it to operate in grid connected or in island mode. So it could be in grid connected or in island mode. In some areas we don't have a grid, so it's permanently in island mode. So I wanted to clarify that if we have a number of renewable systems like wind and solar aggregated and without a controller to make it act as a single controllable entity and to enable it to connect and disconnect from the grid. So from our definition, that type of system is not a microgrid. Next slide, please. So microgrid is gaining more popularity because there are needs for more redundancy to protect critical infrastructure and to open new value streams. So in many areas, the critical infrastructure is vulnerable to major disruptions, such as major storms and earthquakes, and also disruption came from the type of physical attacks and the cybersecurity attacks. So microgrid are now being looked at as a neutral, the way to create a grid that are neutral to generation sources while maintaining reliability of the grid to take advantage of the local resources such as solar and wind. And also, customers are now looking at opportunities to provide grid services such as ancillary services like frequency regulation, black start, capacity market, and other type of services, and also at the same time provide reliable and resilient power to its tenants. Next slide, please. So some of those general features of a microgrid, Jaina mentioned about the point of common coupling. It's a PCC, which is the single interconnection point to the larger main grid. The other components that we see, different sizes and different type of technologies, are energy storage systems to provide short-term and long-term capacity to basically go in from grid connected mode to island mode, and also to be used for shift load peaks. DER, other generation sources, both from fossil, such as natural gas, diesel, and renewables like solar and wind. And the type of controls, we normally have the primary control. So the control systems, primary control systems, are located at the DER levels to respond quickly to changes in microgrid frequency and voltage. So normally they are the control at the energy storage or solar inverters level. And the secondary control level are higher control level that are used to optimize the microgrid performance based on its operating objectives. So, for an example, this type of control can tell the solar or energy storage system to make a decision whether to buy the electricity, sell electricity, or store the electricity at a given moment. And then the system protection is, to support the microgrid for different type of faults during the island operations. Next slide. So operation modes of a microgrid, we mentioned grid connected and island operation mode. In the grid connected mode, main grid provide the primary control for frequency, and the microgrid primary control is available for control voltage, and also microgrid secondary control is used for optimization of the microgrid DER, such as solar and wind or energy storage. In the island operation mode, microgrid now provide primary control for both frequency and voltage, since the main grid is not connected, and the secondary control is used for optimization of the microgrid DER. Next slide, please. So currently, microgrid can serve a crucial recovery center during major weather or man-made disruption that mitigate damage from storm and minimize impact from bad actors targeting the grid. But in the future, DOE R&D program is working on technology development on microgrids to help seamlessly to communicate with the macrogrid, the bigger grid, to provide services to the grid operator to improve cost benefits of microgrid installation, and therefore provide low-cost solution for grid management and damage mitigation. So in Jaina case study, we see that the microgrids there is not really exporting power back to the grid due to the current regulation there. But in the future, we see that microgrid can operate in parallel with the grid and can provide more than just importing, but can export, and provide services to the grid so that it can compensate for the services, therefore lower the cost for that. And so with that, we are now looking at technologies to allow that to happen. Next slide, please. So I'll focus in the microgrid programs are remote off-grid microgrid technology development, grid-connected microgrid, and a network microgrid. And also we are working to develop the resilient tools to support communities, as well as standards and testing. So today I'm gonna just talking about the one area, which is the remote off-grid microgrid. Next slide, please. So in this area, our overall objective is to meet the community-specific goal. In Alaska, for example, the goal is to achieve reduction in total imported fuel usage by 50%, while lowering system life cycle costs and improving reliability and resiliency. So that's a very challenging goal. And this project has 4 different partners. One is the Lawrence Berkeley National Labs, and then we have what we call the GMLC, which is the Grid Modernization Lab Consortium. It's a consortium that combine working to work with multiple national labs, with DOE national labs within the U.S. And then we have Sandia National Labs, and then we have the Alaska Microgrid partnership under also with the GMLC as well. So those are the 4 different projects that I'm going to talk about today. Next slide, please. So the first project, it has a long name. It's a Remote Off-Grid Microgrid Design Support Tool. So we are leveraging the tools that we have developed in the past, and with more development to deliver an optimization-based design support tool for remote, resilient, and reliable microgrids. Basically, this is a focus for a smaller community. So in phase 1, which is from 2015 to 2016, the focus there is to formulate the tools, and then adding other type of new features, including multi-nodes, power flows analysis, and contingency analysis. In phase 2, we basically developed the tools and do validation and testing and transition end to user. And all the project has been completed in May 2018. We have published user manual, and we have training classes for the tools. And in this project, we have Lawrence Berkeley National Labs, Los Alamos, Argonne National Labs, and Brookhaven National Lab as the partner. And also we have Alaska Center for Energy and Power, and GE, and Burns Engineering as the industrial partner. Next slide, please. So what this project is all about is to address how do we do how do we develop a tools that can help community to have a multi-node modeling for things like community microgrids. And in this tool, we are able to provide optimal DER placement. We have both AC and DC components. We're looking at the security constraint of lines and generators, and we provide a topology design for the whole microgrid. We also address the uncertainty of renewable resources and fuel supply, and also have the geographic information system so that we can have location of the systems and devices within the microgrid. So this tool is now is available to provide optimal off-grid microgrid design. So it's replacing existing back of the envelopes and non-optimal calculations. So with this one, community can use the tool to basically have a pre-feasibility study to see whether microgrid is feasible in the community and how much it would cost, what type of resources that we need. And so with the tool, we can help reduce the capital cost and risks associating with the microgrid project deployment. And it can remove barriers to microgrid assessments by lowering microgrid soft cost, and the tool is freely usable and downloadable from the lab website. And so also we have now reliable, resilient microgrid design that can reduce the cost of critical load shedding, due to component outages. So next slide, please. I want to talk a little bit about the tool because now, anyone can download and start using it. So a little bit about the tool. In fiscal year 18, the tool was have some of these features. So it has the release standalone desktop interface to make it easier to use. It has the different type of versions with improvements. It has user registration automation and user support built into the tool. So we have so far more than 1,800 users across different versions and more than 37,000 runs executed. And the user base was growing, rapidly until recently. And basically, we have a lot of requests from the labs for user support. And so on the right side, you see that number of jobs completed. In June and September and August, the highest. And there's a lot of user support activities in September 18. Next slide, please. So this tool has 4 versions of expertise and complexity levels. We have a basic level, intermediate, advanced, and full level. So depending on the level of sophisticated of the users, different type of level can be accessed through the manual and tutorial videos available on the screen. Next slide, please. So the first project was focusing on off-grid, microgrid, small community. The one that we have right here on the screen is the larger project, and it has a long name again. Resilient Alaskan Distribution System Improvement using Automation, Network Analysis, Control, and Energy Storage. So the objective of this project is to do a field validation of resilience-based design and operation, leveraging resources from multiple network microgrid. So the scope of the project is as follows. We wanted to look at the framework for resilience, because a lot of community confused when they talk about resilience. How do they approach resilience? And this project is to trying to attempt to create a framework for the design and operation of a microgrid. And then we also have a first time that we're looking at how can different microgrid can be networked within the distribution system, leveraging different type of resources, including hydro, diesel, energy storage, and micro phasor measurement units. Then another component of this project is to look at the cybersecurity architecture, and also using the hardware-in-the-loop testing capability at Idaho for rapid prototyping of controller for microgrid and cyber vulnerability testing in real-time cybersecurity environment, and also do validation before actual implementation of the project. So we're happy to see that Idaho has been used by Blue Ranch ranchers here, and they are a partner in this project as well. So we have multiple university. We have New Mexico State University. We have Florida State, Washington State University. We have Idaho, as well as Pacific Northwest National Labs and Sandia National Lab partnership in this project. And there are multiple partners from the city, from the co-ops, and industrial partnerships on the right. And I think the key is to have a list and a good working partnership among multiple organizations, and each one has specific role to play. So next slide. So this project, the significant impact of this project is that it has addressed the issues of how can multiple microgrid can network together, either loosely or tightly networked. So loosely, it's like there's no combined control between different microgrids, and tightly networked is it's being controlled by single controller. So a lot of times in Alaska, we see that it's very expensive to build multiple microgrids, and they wanted to explore. AVEC wanted to explore the ideas of if we can build a microgrid in an area where we have sufficient resources like wind and solar, and that can be tied with another, system, the community nearby. So that's the idea. Also, we wanted to adopt the early stage technologies such as the distribution PMUs. PMUs is basically, sensors. It can record voltage, current, phase angle very quickly, and can, provide the status of the grid quickly with the timestamp and like a GPS. And also, this project is the integration of energy storage, fast sensing and control requirements, smart technology into the existing grid control system. Cybersecurity is also a major component, and then through hardware-in-the-loop testing. And so, things that are going to be coming out of this project is a framework, like I had mentioned. How do we approach resilience from the perspective. How can I help the community to reduce the outage from 3 days into one hour, for an example, and how do we implement that 1 hour into the design of a microgrid? And then there's a way to deploy the methodology for network microgrid for the future project. Next slide, please. Oh, are you already in the? Okay, that's fine. So for this project, the approach is, we look at the resilience from the beginning. Can you back up one slide, please? Yes, thank you. So here we look at the resilience as a framework, and the way we design the system is based on that. So we look at where are the critical infrastructure in the grid system, and how can power be provided through these critical infrastructure first. They have a high priority to be protected. And so in the case of sensors and micro PMUs, they wanted to be able to predict when there will be sunshine, where's the wind blowing, or the hydro availability quickly. So these sensors are also being incorporated to let the controller know what are all the status and what the loads are changing at very quick time. And then looking from all the configuration with the data and from the sensors, be able to tell the operator, how do we best protect the system by using smart switch and recloser to protect the critical infrastructure when there's an event. Next slide, please. So, like I had mentioned, having partners with specific roles. In this case, we have City of Cordova, providing the demonstration site, engineering support. Cordova Electric Co-op, also supporting the design and implementation. AVEC, provide the remote sites and support for the feasibility study. NRECA and Siemens, they all have very specific roles that they play to ensure that the project is successful. Next slide, please. So there's another project that we're working in Alaska, which is St. Mary and Mountain Village. So in the St. Mary case, the population is 550 people. The base load is 600 kilowatt. That is for the winter nighttime heating. And the Mountain Village community is about 820 folks. The base load is about 500 kilowatts, also for winter nighttime. So there's a challenge there in this project. Both villages are rural, currently supplied by diesel gensets, and the fuel are shipped to Yukon River, and there's a long period between August and April that ice in the river. There's no fuel can be sent up, and it can be critical if fuel is run out during that time frame. And also they are facing with very high energy cost, which is more than 25% of household income. So next slide, please. So in this project, we have the three-stage plan to lower the cost and increase reliability and resiliency for the two villages. So we have the wind turbine generation, we have a energy storage system, and we plan to network them together between the two villages via a 12.47 kV tie line. And so eventually, villages wanted to turn off their diesel systems and use solely wind and energy storage, and could be solar in the future. Next slide, please. So in this project, Sandia and Village Electric Corporation, AVEC, and Alaska Center of Energy and Power partner to study and demonstrate advanced renewable-based microgrid. And so we are developing a open source grid bridging system, optimal sizing tool. So basically, where to put and how big is this energy storage system would be in this microgrid. And we're looking at ways to have renewable system to provide voltage frequency in the absence of the diesel genset. That is the new technology development. And so once this is done, we wanted to replicate this system throughout Alaska and beyond, and then develop the standardization, design, and workforce gaps to help other communities, not just in Alaska, but maybe in the tribal area as well. Next slide, please. So the last project that we had is which is focusing on reduced cost of energy for isolated community by establishing information sharing resources for replacing imported fuel with local energy resources and energy efficiencies and optimize energy usage. So in this project, we have transition processes and methods for sharing lesson learned and design information to the Alaska Energy Authority and University of Alaska. We have built a data gateway, basically a website and repository to allow all the stakeholders to collect and store information to implement, their own system. The project had technical and economic analysis for two communities. One is Chepanak, and the other one is Shungnak, as an example. And then there's numerous lesson learned and other documents that are available on that website to help all the community. So this one is the partnership between DOE, Lawrence Berkeley National Labs, National Renewable Energy Lab, Pacific Northwest National Labs, and Sandia National Labs, and other partners, including Alaska Center for Energy and Power, Intelligent Energy System, and Institute for Social and Economic Research. Next slide, please. So that's just a snapshot of the project that we have in the remote off-grid microgrid arena. In this slide, I wanted to summarize where we were and where we're going in the microgrid program. So in the past, we've seen that microgrid has been and is a focus for campuses, military bases, which has a single owner. We have focused our effort in develop design tools. In the present time, we wanted to focus on R&D technology development into how can we help microgrid to reach more commercial applications. And we are now looking at technologies to be integrated with utilities, distribution utilities, and for grid connected and grid off-grid applications. We continue to partner with local, state, and regional partnerships. In the future, we are looking at multiple microgrids working together, developing the technology for that. Developed ways to improve the value streams for microgrids, and so that we can support the new ownership models where different entities can work with utilities to provide energy for wide area. So that's where we are today, and I'm happy to answer questions at the end.
Thank you, Dan. I appreciate that. We will take questions, but not until the end of the next webinar, or excuse me, the next presentation. Just in the interest of making sure we have enough time to finish. So, audience, please do submit questions in a written format that I can give to Dan during the question and answer session. All right. So next we have David Thomason. Let me bring up your slides. Hold on one moment. All right, it should be showing up shortly. You're all set, David.
Well, thank you, James. It is exciting to be here, and I'm very excited to know that I really don't have to explain what a microgrid is. I mean, the last two presenters have pretty much covered every area I can think of on that. So for those that are participating, welcome to Citizen Potawatomi Nation land. We're calling from Shawnee, Oklahoma. And who we are is nearly 34,000 strong, federally recognized tribe. Our tribal jurisdiction areas, they're about 900 square miles in central Oklahoma, near Oklahoma City. And so we say go Thunder and all that stuff around here, since it's part of who we are. Next, please. We have a unique legislative governing body, we think, among most Native American tribes, whatever there are, 570 odd today in the United States. We have 16 elected representatives. 8 of them reside outside of our tribal jurisdiction area. 8 of them reside in. 3 of those 8 that reside in are our executive, the chairman, vice chairman, and treasurer. And what we've found is that it is a balance between those tribal members, those 34,000, of which 24,000 do not live in our tribal jurisdictional area, so that they are represented as well in the things that we do and able to participate in decisions long-term affecting our tribal sovereignty and self-determination, even out there. So we believe we have a 3-part, very unique tribal government, and we're very proud of it. We're also proud of the impact on our community. As you can see by the slides there, from just going back to 2003 to last year, our economic impact in our tribal jurisdiction area is over $500 million a year, and literally 7 of every 10 jobs created in the Shawnee area over the last 15 odd years have been Citizen Potawatomi. We've given $9 million in charitable contributions. That's annually, too, by the way. We have a tag for all of us within the tribe to do that. We support more than 3,400 jobs in the local area. And as you can see, some of the other things there that we do as far as exclusivity fees to the state of Oklahoma for gaming and such as that. So we're very proud of who we are. We're the 9th largest federally recognized tribe in America now by number of enrolled members. Next, please. John Rocky Barrett is our chairman. Been chairman for 35 odd years, and has been the leader, frankly, in what we're going to talk about today, the tribal Fire Lake Energy Microgrid. It's been on his radar for us to be an independent electrical utility for the last 12 years. I've heard of him talking about it, and probably further back than that. Next slide, please. Linda Capps, our vice chairman. We are primarily a matriarchal tribe, as opposed to some of the patriarchal tribes. And she's here every day working hard, and we love having Ms. Capps doing the legislating that we have for us. Next slide, please. We're proud of D-Wayne Trousdale, our secretary-treasurer, member of our tribe. He also happens to be the CEO of a billion-dollar plus company in the wood products business. So we have a lot of leadership talent at our executive level that has to do with business acumen, and we believe that we've displayed that through the year. Next, please. What I'm going to show you next, in that comma's in the wrong place, that's actually 391,500 basically, and we've added. So our Grand Casino is about 400,000 square feet, and the items that I'm going to show in the next panels are those items that are either going to be fed through our microgrid utility or our various essential services. Next, please. Bowling center. Next, please. We're going to, for the sake of time, we're going to go through these pretty quickly so I can leave any question time that any of the participants might have. A 5,000-seat arena where we think Willie Nelson's coming in February. He's still around. He's still alive, believe it or not. So Willie's going to be here February 22nd. If any of you guys want to come to Shawnee and join us for Willie Nelson. Next, please. We have a fabulous Fire Lake golf course on our tribal reservation area, and that's just a picture of our clubhouse. Next, please. Fuel, we have several different fuel locations in our tribal jurisdiction area, 4 or 5, along with probably the largest grocery store chain in central Oklahoma, our Fire Lake Discounts Food that we also own. Next, please. Our Potawatomi Heritage Center is our award-winning museum that has everything to do with our northern woodlands culture. We are, of course, a northern woodland tribe, birch bark canoes, wigwams, and that kind of thing before we were removed ultimately to Oklahoma. And so our heritage goes to the northeast and maple syrup and all that kind of stuff. And so with that, our tribal roles and our museum we're very proud of. Next, please. One of the reasons for this microgrid, not the least of which is, to get some level of independence over our electrical usage and mitigate long-term rate increases, is our clinics. We have 2 fabulous clinics. This is the East Clinic. Next, please. Next is a picture of our West Clinic. Next page, please. Workforce development and our social services. Next, please. Transportation, where we take care of a lot of transportation of elderly, handicapped, ICWA, you name it. We've got a lot of services associated with that. Next, please. And our brand new imaging center, that's a current picture that was taken just a couple of days ago at our West Clinic. It will be CT MRI scanning area. and we're bringing that online as soon as possible to augment the other parts of our tribal medical care. We have a large facility of dental, and now we're going to have imaging. We have pretty much everything within our tribe other than inpatient hospital care. And we have such a close proximity to Oklahoma City, only being 20 or 30 minutes from the city, that's available there and in our local town. So these are all items. If your next page, please, that we are going to be connecting to our microgrid for the sake of resiliency. Right here's a picture of one of our senior housing complexes. We have 78 of those particular ones in that space right there. Next, please. And you can see solar panels on some of our elder housing. We've got 36 units that have full solar. When we originally put them in, Oklahoma was a net metering state, and I don't know if it was because of us or not, but the local incumbent public utility went to the local public service or corporation commission here in Oklahoma and immediately came with the legislatures, and they did away with net metering. So now we're at a very low value on resale. So the value of PV for us here in central Oklahoma residentially is marginal at best. But we love to take advantage of the sun when it shines, and it shines a lot here. Next, please. In the past, we have participated with the Indian Energy Agency, Department of Energy, on several projects. This is a geothermal pond. It was our original one. This geothermal pond provides all the chilled water, cooled water. These are the external base evaporative condensers that are underwater that you see for over 2 million square feet of our properties, our administration buildings, the Cultural Heritage Center you saw, a 250,000 square foot grocery store, the 50,000 square foot arena, and another small casino are almost all done with geothermal. As a matter of fact, most all of our senior housing, over 170 units, I believe is the last number I got, we have geothermal recirculative type what am I looking for? Heat pumps. That's the word I was looking for. Heat pump system where we actually use the ground as a condenser. And so we have about an average of 56-degree water here in central Oklahoma with a very good water table and lots of capacity. So our 56 degree in the winter is nice for additive heating, and in the summer it's nice for additive cooling. And it makes all of our electricity bills look lower, and it's just one of the investments that we've chosen to make to be the best stewards we can of the property that we have here on our tribal reservation area. Next, please. This is some of the options as we were looking through how do we go about doing something to make our electrical system more resilient, number one, because we are subject to, we don't have tsunamis like you guys in California do, but we do have ice storms regularly, and we have tornadoes regularly, and they're both very devastating. So a lot of our underground, our distribution, even at 12.5 kV, is underground here. And so we engaged with the TEDC, a tribal energy, capacity grant that we received right at a year and a half ago, contracted with a company to do a feasibility study that would look at options assessments for various types of fuel that we might use. And we looked through there, and as you can see, solar, and I'm going to show you something about that in a moment. The yellow is slow down or speed up, and then green is good, and red is stop. Kind of like a stop line. Greens go, yellow is go faster, and red is stop. So we kind of stopped at the wind there, which we really did actually have an NREL wind power study done. So we've done our homework, I think, over the last year and a half to really get ourselves to the position of knowing where we want to go. Biomass is not a consideration here. We don't have any trees to speak of. Hydro is not a consideration because we don't have any riparian water out there running around and get our hands on to speak of either. Next, please. As you will see, we had NREL help us with a chart of our solar resources, and right there where that big star is where the Citizen Potawatomi Nation resides in Shawnee, Oklahoma. And as you can see by the color gradation there, we're in an okay area. It's certainly not as good as west. If you go to Oklahoma City and further west, you get to the Oklahoma and the Texas Panhandle. Those guys have a lot of photons floating around out there available. So we looked at solar, and it didn't seem to be like the thing we could, really hang our hat on right now because of the price point of PV and then any additive storage. Next, please. In wind resources, we are now the number 2 state in the United States. Oklahoma has 8.7 gigawatt of connected and spinning wind power assets, and there are more being built as we speak, and a lot of pretty good-sized projects. However, that star there shows you that we're not in the windiest parts of Oklahoma. It's out there where the purple and pink and all those fun areas are, closer to the wind tunnel zone of America. So we looked at that. The initial investment in getting into wind power did not make sense because our wind power study showed us that we just wouldn't be able to have any repayment ability. The metrics didn't work. Next, please. So we did a job of looking at natural gas. Oklahoma, being a natural gas exporter and a lot of oil companies here, what we did is have one of our analytical helpers go out and look at the OTC Global Holding Natural Gas Forecast Futures. And what we looked at and what we believe is going to happen is that gas at the Henry Hub, I've got a long-term contract offer now for gas as low as, mid $2 per decatherm, or that's, million MMBTU. And we see that holding right now into 2018, the end of 2018, where we are now, below $3. And everything that we can see tells us that natural gas is going to be the fuel that we can use. So, move along, please, to the next one. With that in mind, what we did is look at, okay, we want to build a utility here. We want to build a microgrid. We need resilience for our tornadoes and ice storms. We need the resilience for our grid, for our senior housing, for our clinics that do not presently have any kind of backup generation or resilience on the grid on them. And how do we do that? So we looked at our primary microgrid area, which is right in our main reservation, and you can see to the right there, everything on the bottom from primary meter up to warehouse, the ball fields, bowling, clinic, public works, so on and so forth. And those are our peak demands. We have a peak demand somewhere of around 3,000, 3,400 kW in this specific microgrid right here. Next, please. And as we look at our energy usage in there, that's the kilowatt hours per year that we're using or per month. And of course, down here, we have a high air conditioning load in the summer. And we have to deal with that with peak demand. So we're sitting at about 3,500 kW as far as what our peak demand is right now, and without adding any more load. And then move on to the next slide, if you would. This is our deployment area. Our deployment area, the way I have sized it up, is basically at 10 MVA or 10 meg. So everything that you see in pink there is existing overhead distribution. The things you see in purple are existing under distribution, and all that is at 12.5. So in the far bottom center of the panel, which you really can't see right now because I don't have a picture of it, is where the substation, that will more than likely be our point of common coupling, because that is where the local incumbent public utility has a substation with capacity in it for us to have a point of common coupling. And from there, we're in the process of negotiating with the local incumbent utility to secure those distribution assets that are in pink. A good many of them are underground. They're going to go underground as we build our microgrid utility, rather than purchasing overhead distribution, we're just going to go underground and be done with it because of the resiliency factors that we talked about of ice storms and tornadoes, so that we can keep things like our important clinics and our senior housing up and online. That becomes very important. Our design within that deployment area, I already have existing 2,500 kilowatts of diesel emergency backup that is grid connected and parallelable right now. So it will serve as a hedge for me to either load shed or inject back into the grid to the point of coupling. And then if you'll go to the next panel, please. The generation plant that you see in the bottom is actually going to be, is going to start out as a 4 meg natural gas reciprocating generation plant. We have a large natural gas pipeline very near to where the physical location, that was one of the criteria we had for locating the generating plant where it is, was the physical location close to the fuel source, obviously, and then, of course, close to the load. So it will be adjacent to our distribution. In that, you see there's existing 69 kV transmission lines that feed the transformer, and the delivery point up there is where you see that would be our point of common coupling. You'll see a wind energy PPA. We have negotiated a 10-year flat rate, frankly, very attractive 10 megawatts power purchase agreement with the ability to expand it to 20 should we need that extra capacity. That wind power purchase agreement can supply, depending on how much wind we have, somewhere over half, literally, of all the kW hours of electricity that we're going to be using. So we're very proud to be able to reduce our carbon footprint, do away with using coal that the local incumbent utility uses as a source for power. Our interconnection substation there, where we have our transformers, we'll have our switching, cutouts, and those types of things that will allow that generating plant, which is going to be sized adequately enough to take care of the whole grid, microgrid. We will island off from that point of coupling and be able to island and indeterminately. Since I have natural gas supply, I can island off for days or weeks if I need to from the grid itself. And we will be resilient and we will be energy independent at that point. You see that I have growth. Those 3 generators or 4 there are in the 1 to 1.5 meg range. We're sourcing them right now for that plant. We'll be breaking ground here in a few days. We're just waiting on a couple of other permit issues. We were the fortunate recipient of one of the 15 grants recently that Indian Energy Agency provided for a cost sharing in a utility generation situation. We were fortunate enough to be able to provide a design that made sense, and we're looking forward to that. That plant will expand up to 7 meg. I have room for that in my switchgear. We have a couple, 2,500 more meg of diesel for immediate and emergency load shedding. So it gives us roughly a 10 meg microgrid where we pick up a good measure of our local tribal loads. Above and beyond that, if we expand our tribal utility and get more loads in our development, we have an Iron Horse development that is a place for other businesses to move into an industrial park, if you will. We're making agreements now to go out and purchase additional capacity to be able to supply those loads. But those loads will be supplied by Fire Lake Energy, which is our branded electrical microgrid utility for the citizen Potawatomi Nation. Beyond that, let's see. Of course, the obligatory savings are going to be part of that. We calculate roughly, well, we have it specifically, but I'm telling you roughly, somewhere between 20 to 30% that we're going to be able to save over what our incumbent utility is charging us. And one of the other issues they have is I have about 70 different meters located within my distribution area with 14 different tariffs on them, all the way from 14 cents a kW hour approximately or annually down to about 7 on our large loads. So we're going to aggregate all of those loads so that we own those meters and take care of the distribution, and then purchase power from the grid, from the Southwest Power Pool as a market participant at a much lower price. And we have an expectation of saving tremendous amount of money. Also, we have mitigated the exposure that most all of us have in America to public utilities raising rates. Those rates will now not be determined on somebody's return of equity needing to go up from a public utility. It'll strictly be fuel. And so we see fuel as being a very stable constant in the future. We like the idea of being able to add natural gas to wind, and those two items will be our primary source of electrons within our grid. And basically, we're going to minimize coal and nuclear and those other items as much as possible through doing that. So savings, employment, we're going to add some jobs because of this. We have ability now to expand into our future, but more than anything else, our tribal self-determination and sovereignty allow us and those of you other tribes out there to be able to push this. We've spent quite a few years thinking about it. It's been about a year and a half into design and thought and feasibility. And December 1, we actually kick off our project, which is going to last about 2.5 years or something like that. And we'd love to come back and explain to you how it's going. But we see it as being a great level of self-determination and independence for us as a tribe. We are already successfully in the water and sewer distribution utility business in our territory, and this will just give us another level of tribal independence and sovereignty. With that, we'll take any questions.
Thank you, David. I appreciate the presentation. Interesting project. So yeah, as you said, with that, we'll now field questions for both David and Dan. Let me bring those up, but feel free to continue to ask written questions as we go through these. All right, I'm bringing up a slide here to show where the webinar will be recorded, and we'll have access to the recording and slides in the future, just for the audience while we go through the questions. All right, so a couple questions here. On that wind project you mentioned, David, can you talk about where the wind is from? It's off reservation, right? It's just a private PPA that you guys have.
Yes, it is. It's negotiated with, let's see, who is it called? NL Green Energy. NL Green Energy is one of the larger companies in America that is basically a merchant wind power facilitator. So it is a merchant agreement for X amount of kilowatt hours per year. And it's at a flat rate that's very appealing. The last one that we looked at physically is in Kansas, but it could be Oklahoma or Texas or wherever you can, wherever your best node is in order to place those electrons into the grid and then pull them back off. It's not a point to point. It's not like there's a generator down the road 2 miles and I can run an extension cord and use that exact electricity. The wind power purchase agreements go into a grid, whatever your ISO is. In our particular case, it's the Southwest Power Pool, who covers about 14 states from North Texas all the way to Canada. All right, power goes into those pools, into that grid, and then the Southwest Power Pool organizes, distributes, and you put those in at that node and then take it off at another node. So that's the way that actually works. It's pretty tough to actually physically put a wind power generator on your site unless you happen to be building something. Now, if you're one of those tribes with a lot of sun and a lot of wind and you're out west, it might be ideal. We just aren't in that situation where we are here.
That's it. Thanks, David. Question for Don here, or excuse me, for Dan. is DOE changing their definition of a microgrid? Previously, a microgrid had to both island and parallel to the grid. Islanded generation is not a microgrid, according to this question.
I don't think we have this definition for a while now. I think it's maybe 2010 or so, when we have a panel of from industries and utilities and other organizations that we formed that definition a long time ago, and I don't think we have changed that since then.
Okay, thank you.
By the way, James, would you do me a favor and go to the end panel, go to the final panel for us here at CPN?
Yeah, hold on a second.
There's a panel there that has my contact information that I would very much appreciate and enjoy anyone who has any specific technical background information, because that's my background on design of this system, to give me a call or reach out to me via email, and I'll respond back to you, because I didn't want to bog down the presentation with too much technical jargon and a lot of utility acronyms. There we are. Fire Lake Energy, give us a call. Thank you so much.
Yeah, no problem. Let's see. We got quite a few questions here, so let's go through them. Does the pond-style geothermal system work in northern climates? Are you familiar with how transferable that technology is?
Oh, probably it works great, because you've got a large differential up there, but up north you don't need ponds. You can use air-to-air differential as far as transposing or transmitting heat to cool. It can be outside air-to-air, but I'm sure water would work okay. But down here it works well because it's hot. It's 100, 110, 120 degrees outside in the summer. And if I can reduce my load on my condenser, I've made it more efficient. And so consequently, we were able to do that pretty effectively and take the differential between hot and cold. But up north, I've seen them do it with air-to-air transfers up there. When it's cold outside and you need to cool something off, just send it out there and transfer it.
Gotcha. Question for Dan. Are there any Alaska Native tribes or other organizations that are considering using nuclear energy in their microgrid system? And have they taken advantage of the new design for small modular reactors?
I have no knowledge of any tribes that are looking into that modular or nuclear, technologies in their microgrid design.
Question for David. What happens if you lose the natural gas pipeline through a leak, earthquake, etc.?
I'm glad you asked that question, because I have an answer for that. I just so happen to have a 30,000-gallon propane tank adjacent to the new generating plant I'm building, and we are going to have the ability to fuel that rascal for, I think if I'm generating it somewhere near 4 meg, my 30,000 gallons is going to run me for a couple of days. So I've got a couple of days of interruptible emergency fuel available. That's a real good design, particularly if one is buying interruptible gas on the open market, not uninterruptible. You can buy interruptible gas where people have the ability to cut you off, and if so, you can use LNG, which is being used a lot now, or propane. LNG is a little bit less expensive. And then run a spark-ignited, reciprocating generating plant on LNG for the couple of days. And it might be that that's cheaper long-term to go with an interruptible contract rather than uninterruptible. But thank you for asking. We have thought of that, and it's important.
Great, thanks. What is the cost of per kilowatt hour there for the tribe? I think you mentioned you have 14 different tariffs, so maybe. Well,
it ranges right now as low as 5.5 at our Grand Casino. That is a huge. But that's a 6 meg load connected by itself, and I have the next to lowest tariff that the local incumbent utility provides it's not part of this project. It's 6 or 7 miles away. And within our reservation, the kW hour rates are anywhere from 7.5 to 14.5 cents per kW hour annualized. So we're going to be able to significantly reduce that couple $1 million a year we're paying in charges to the local utility by being an independent utility.
Gotcha. Another question for you, David. In terms of feasibility, would the natural gas project have been a go without owning your own pipe to deliver to the generator?
Well, we don't own our own pipe for the natural gas. I mean, and the answer is yes and yes. The natural gas that we're buying is transport gas in the state of Oklahoma and in about 25 other states, as I understand it. A gas, when you get above a decatherm of load a day or something like that, there's different criterion you can buy as transport gas, where the local distribution company is obligated through FERC to provide that gas to you, and you buy it in the open market. So we just so happen to have a lot of gas around here in Oklahoma because we're a net exporter of energy. But we're buying it from the local incumbent gas utility. We're paying them a transport fee of, 50 cents or 75 cents per decatherm. And then we've made long-term agreements out on the market with the midstream companies to purchase natural gas to them off the Henry Hub, pretty much off their prices. So the answer is yes. It wouldn't matter where you get the gas from. And the rule of thumb is this: natural gas costs you about 3.5 cents a kW hour to produce electricity through a reciprocating engine. Electricity through a diesel engine, even at $2.50 a gallon, costs you about 22 to 25 cents a kW hour. So there was no question that you go with the cheapest fuel available. Propane is more expensive. LNG is more expensive. The 1,000 BTU methane available on transport gas is by far the best thing, and it looks like it's the most available.
Great. So I'll ask one more question, and then the remaining questions here are pretty specific, and I'll just send them to the individual panelists that are applicable.
Okay.
And they should be able to get back to the questioner. So for you, Dan, what was the model of turbine that AVEC is using in their project? I think probably referring to the AVEC project. And do you know what their kilowatt hour cost is on that utility?
That I need to get back with you on.
Sure.
Yeah, I don't have it on top of my head.
Understood. All right. So with that, I'll go to our wrap-up slides, and like as I mentioned, we'll provide these questions to our panel. Hold on, let me bring up our final slides here. I've already asked questions. So I'll just put up the link there to the webinar slides that'll be available in the future, and you should get a email with the link to the webpage where you can get this recording. We appreciate everybody's attendance today. We are interested in your suggestions on how to strengthen the value of this training, so please send us your feedback. This webinar has been the final webinar of the 2018 Tribal Energy Webinar Series, but we are currently planning for the 2019 series, so please keep an eye out for details on next year's webinar topics and schedule. Thanks to all of our speakers today and their excellent presentations and their time, and we look forward to the audience joining us for additional future webinars. This concludes the webinar for today, and have a good day. Thank you.
All right. Thank you. Mm-hmm.
I guess it's over.
Yeah.